So we're not done yet, even though that sounds like a good way to finish the day. To quote science fiction artificial intelligence, this conversation serves no purpose anymore. But we do have one other talk. We're going to finish on a high too. I think today has been quite fantastic, and I appreciate everybody being here and asking the questions. I appreciate all the speakers. But we do have one last presentation. I want to make sure I get the name right. I know it's behind me on the screen, so you can read for yourself, but one of the big things we pride ourselves, in Houston is not just NASA, but how NASA is working with commercial enterprises, and that's a big part of what we try and do. We've been doing this all week with delegations from Hungary, delegations from France, and our friends from Italy. And so I'd like to welcome to the stage Dr. Roberto Provera, who is the Director of New Initiatives, Partnerships and Innovation, Exploration and Science at Thales Alenia Space, Italy. And that will close out our program today. So thank you very much.
Good afternoon. Thanks to Professor Alexander. Thanks to Antonella for your kind invitation to speak today. After such interesting panel, it is difficult, and I know that I'm the last one before we break, so I'll try I'll try to keep you awake. Okay, for those who are not familiar with Thales Alenia Space, Thales Alenia Space is a joint venture between two giants in Europe, Thales, the French Thales, and the Italian Leonardo. We are with Telespazio, we formed the so-called Space Alliance. That means basically two companies together cover the end-to-end of space systems. We are about 8,500 people, and we are spread all Europe and in the States. Especially our headquarters are in Rome, and the Center of Excellence of Exploration is in Torino. We are proud to say that we cover quite a lot of the space exploration activities, and when we say we imagine space, we have in our mind the exploration. And when we say exploration, we mean many things. Science, we mean robotic exploration, human spaceflight, re-entry vehicle, and on-orbit servicing. And the destination have been already mentioned several times today. And we first of all are focusing now on low Earth orbit, but we are already targeting Moon and Mars, and I'll try to explain in a few moments what our plans and what our activities are in these days. Maybe it is not known, but Italy had a great role in the development of the International Space Station. A large percentage of the pressurized volume of the International Space Station has been developed in Italy and by Thales Alenia Space. You see on the screen a photo of the International Space Station with many elements that have been developed by Thales Alenia Space in the last years. And in these days, we are continuing to support the International Space Station through the supply of Cygnus, the cargo vessel for resupply of the station. And that is important because it shows a sort of transition from the government-led activities to the commercial B2B activities. And it is important to say that we started to be provider or supplier for the government, and we ended in the last years to be a partner of US companies like Northrop Grumman, for which we develop the Cygnus vehicle. And that was, it is important because it shows that building on national investment, we are able to compete worldwide as Italian companies and to bring success to our country thanks to the investment that our government did in the last years. This is the vehicle I was just referring. This is a partnership between Italian industry like Thales Space and Northrop Grumman. It's the vehicle that supplies spares, food, crew items to the station, and we fly twice per year. And at the moment, we are under contract with Northrop Grumman, with NASA, for the production of 32 cargo vessels, and at the moment, about 20 have been already flown. This is a picture of Luca, and it wasn't planned to have Luca here. And I think it's important to say that beyond the development that sees Italy as a player, major player of the space station, we have also the capability to support the operations. And we have a small Houston in Torino. It is the name is Altec. It's a mission support center in which we support the astronaut and the flight controller of Houston in their daily operations. By the way, I think behind Luca, you may see how the space station looks like, and I think our space architect could say something about the actual design and how it is crowded. This is something that is, I think, is important. When we see this, let's say, futuristic graphic for the space stations or lunar habitat, normally we see very large volumes, very nicely designed. I think at the moment the challenge in the next years, since the technology for the propulsion is the one that we have just seen in this morning, the challenge will be to have very small spaces really well outfitted, so that astronauts can stay there. You may imagine that the first lunar habitat, we will see it in some moment, is something like 3-meter diameter for 8 meter, and people will have to stay there for 1 month. So the challenge is how to make a living quarter habitable for a long period, but in a, let's say, in a functional way in which humans can stay, and the space will be limited. So small spaces for a long destination, for a long time, for a long stay. The model in which we are using now low Earth orbit is changing. Someone has already addressed the point. We are in a transition from a government-owned infrastructure like the International Space Station, and now we are going to a private space station, or let's say commercial space station, and the Axiom station is the first under development. I see that an Axiom representative is here today. I'm glad to say that we are collaborating with Axiom for the development of the first 2 elements. We are developing in Torino the 2 structures for their initial 2 modules. This is not science fiction. What you see here is a picture of our facility in Torino, in which you may see the initial segment of the Axiom station under production. And it's a pity you cannot see, but here there is a segment for with windows. It will be the first time there will be a 360 degrees element, windowed elements, so that the astronaut can see outside on the overall perimeter of the station. What's next? We are already working in Europe for the development of a, let's say, less dependent space system development. That means that Europe wants now to have their own capability for access in space, especially low Earth orbit, with European elements. So we are developing now initial concept for cargo, then crew for low Earth orbit, and with the capability to complete the trajectory to moon orbit for both cargo and crew. What you see there is a model that we are developing. We have developed in Italy for a crew capsule. It's not just a mock-up, it's a technological development in which we showed that it is possible to weld a different material through friction stir welding. As a complement to that, we need the capability to return to ground what we do in space. And we are proud to say that at the moment, we are the only company in Europe that can handle the re-entry technology. We flew in 2015 demonstrator, re-entry demonstrator, and intermediate experimental vehicle that you see on the screen. That is after the flight during the recovery in the Pacific Ocean. And now we are working at the evolution of this. It will become, the name is Space Rider. It will become an operational vehicle in which we can manufacture on orbit materials. We will use it for biotech, pharmaceutical components. It will stay on orbit for 4 to 6 weeks. It will be autonomous, and it will re-enter the material that will be manufactured in orbit. The first flight is planned by 2026, so it's under development. The target, now we have already spoken a lot, is the moon, anyway. And we are active to support the Orion mission in Italy and in Europe through the development of the European Service Module. You may see upright what we have in Torino. We are already developing the fifth unit of the service module. One has already flown with the Artemis 1. The others are in line for, and now are in Bremen for the final integration, and a couple have already been shipped to US. We, as Europe, as Italy, have been active in the development of the International Space Station, as I said. We are working at the new commercial space station, but it is important to say that we have already started the development of the Lunar Gateway, the next outpost in lunar orbit. And I'd like to say that this is not just a picture, because if I can, can I have a help here, please? This is a video we took, thank you. We took 1 month ago. That is the structure or the first habitat element that will fly around the moon in orbit, in lunar orbit, is the structure of the habitat and logistics outpost we delivered for Northrop Grumman. So that is not just paper. This is the real flight hardware that will fly in 2026 to the moon with the US rocket. Thank you. I think we can stop here. And as Italy, we are already discussing with the US government, our government and US government are discussing, NASA and the Italian Space Agency have already an agreement to develop the first human outpost on the moon surface. We are already under contract by Italian Space Agency. That is just a pictorial, we don't have yet hardware, but by the end of the 20s, beginning of 2030s, we will be able, in cooperation with NASA, Italy will be able to develop, deploy on the lunar surface the first habitat that will support the Artemis mission when the astronaut will land on the moon through the human landing system that is under development now. It's an important step because from a technological point of view, you may imagine how how large will be the step that we have to do. From LEO to moon orbit, we will have a different environment, radiation, first of all. And when we will descend to the moon, we will have to face dust, radiation. It's a completely different design of the elements that we have to tackle. And we are doing it now. At the moment, we are developing the initial concept. It will be a sort of relocatable habitat so that it can go in proximity to the landing location of the human landing system, so that the astronaut, after landing, they will have a house in which to stay for their exits. Okay. And speaking of different disciplines that are needed to support lunar exploration, you may see on the screen a list of studies we developed with the Italian Space Agency. And it was a sort of test for Italian industry as well, because we decided to team with non-space industry. So, for instance, we decided, we thought, what will we need when we will have a moon base? We will need power, we will need construction, we will need navigation, habitat, of course. And so we decided to team with non-space industries like NLX, that is the Italian supplier for energy. We teamed with them to study how the first energy supply could be done on the moon. We teamed with heavy-duty machine in order to study how we can collect a regolith and to process it to make initial bricks for moon construction. We teamed with the interior design company to develop how the first habitat could look like internally, and so on. It was a quite interesting experience because, first of all, there is a sort of cultural barrier between who does space and the other company. Any field of engineering, any field of construction has its own language, its own dialect, its own way of thinking, and that was the first time in which we tried to contaminate the culture and to put together a sort of concept. It was quite interesting. After that, we continued our effort, and we are still keeping on developing concept with non-space industries. The logistics, I think that whoever will have a logistics capability to go to the moon will help really the development of a lunar economy. And we are now studying a first European cargo to the moon. It will be a medium-sized cargo, like 2 tons on the ground, on the surface. And the first mission is foreseen by 2031. We are at the moment at the concept development, let's say initial engineering phase. Next year, we will have, ESA will award the final contract, and we are bidding for that. The outpost is we have seen already several pictures. That is the final goal. And in order to do that, we have seen already today how many technologies we will need for having a sustainable life on Moon. What we are doing now is to prepare for with those technologies, especially for environmental control, water recycling, air revitalization, and let's say complementing that with studies on human factors and new materials. Last destination is Mars. At the moment, we are preparing the mission. What you see on the screen is a real hardware that was supposed to fly to Mars last year. You know, ExoMars is a big European project. Thales Alenia Space and Italian industry are leading that project. Unfortunately, the project was stopped because it was a European-Russian project, and for the Russian invasion of Ukraine, the project was stopped exactly 2 weeks before we had to ship the hardware to Baikonur. So basically now the hardware is sitting in Torino, waiting for 2028. That is the first date in which we can launch it. The mission is quite challenging. Luca already said that the mission will consist in a rover with a drill that will go 2 meters below the Mars surface in order to search for traces of life. And after this mission, oh, by the way, you can see on the top the real rover that we lost, the drill and the laboratory that will analyze the samples. The next step, we are already again, speaking of the small Houston we have in Torino, this is our control center for the rover operations with a simulant of Mars terrain, in which we'll basically we will prepare the operations of the rover. That is a ground model of the rover, basically the same functionalities, not the flight hardware, but that will be used to test in advance the operations before we send the commands to the actual rover. And the next step will be the collection of samples and return of the samples to Earth. That is planned by the end of the decade. It's already ongoing. We are developing together with our colleagues of Airbus France the carrier that will be the vehicle that will bring the samples from Mars orbit to Earth orbit. It's a joint mission between ESA and NASA. NASA will contribute with the other pieces of the mission. And yeah, I think one very quickly. The other applications we are already studying for the next applications. First of all, it has been already addressed at the point that it will be much easier when the technology will be available to develop and to assemble elements in orbit. What we are doing now is an initial mission. It will be flown by 2026, so it's ongoing. This is funded by Italian Recovery Fund from COVID. And the demo mission will test in low Earth orbit the capability to rendezvous, grasp a satellite, refuel it, exchange, make some maintenance, so exchange some pieces, and raise the orbit, and finally to the orbit. So basically all the segments for a mission that will help sustaining the life, extending the life of the elements, and in long-term, in a longer future, to manufacture and recycle the object that we send to space at the moment. The last technology we are studying now with ESA is a solar-based power system. This is targeting, I would say, 2040 or so. So basically, it will consist in the collection of solar energy for reuse both in space and to send to ground. This is an example of green energy that can be used. Last chart, just to say that when we say Thales Alenia Space is doing this and this, we can do it because we have an excellent supply chain in Italy. We are really good small and medium enterprises that collaborate with us, and we have integrated a great logistics, a great supply chain in our products. And by the way, we are also proud to say that in the last 3 years, we have doubled the orders with respect to Italian SMEs, so that we can really take benefit of the technology that is spread all over Italy. And that's all we do. We say, costruiamo macchine spaziali. That means basically we build a space machine, we build the future in Torino, Italy. And that concludes my presentation.
Sorry, I forgot I was doing the job of the suits did so well earlier. So we have time for a couple of questions. Scott.
Yeah, you talked about the integrating with small suppliers in Italy and making these partnerships with a lot of small suppliers and doing those kind of studies. And to do that, I think correct me if I'm wrong, you had to look at where it is that these small suppliers could fit into your supply chain, where it is that they could integrate into your supply chain. Have you looked at where it is that Houston companies could integrate with you also, either as suppliers or as customers, and provide that same kind of integrated supply chain? Have you looked at that?
It's an interesting question. I would say that just started. I was here, it was 1 month ago, 2 months ago, during the Italian mission in US, and we visited among the other places, Houston. This is when we met first, and it was a quite interesting event because we were exposed to let's say to companies that were not known from our side. Well, of course, we know the major companies in the US. We work daily with them, and but it is difficult for us to have access to the let's say SMEs in US. 2 months ago was the first opportunity we had to get in touch with some of those, and it was quite interesting. We have some contacts now that we would like to develop. I hope that we have, I think, a good model in Italy. Normally, at least once per year, we collect, thanks to the government and to local bodies, we collect all the SMEs that are interested in working in space, and we show them our vision, what we are going to do in the next 5 to 10 years. And we list normally the technology we need, very, very easily. As you said, we need this, and this. If you have this technology, please come and talk together. And by the way, doing this, we met in Italy a company that now is developing a water pump system for our next module. We met. This is quite interesting. We met a company that is working for the safety belts in Formula One, and we asked them to develop a system for restraining the belts for our cargo systems. And so we have several success stories. Just because we could organize a sort of space day in which we said, look, we are going to have this vision, we are having this vision, we go there, and we need these technologies. If it is possible to do something like this in the Houston area, we would be very happy.
So maybe, I mean, So I work with the Houston Spaceport a lot too, and that's one of the things that we're seeing in Houston. But obviously, we're very privileged to have NASA here, right, the Johnson Space Center. But with the development of commercial companies and the way that the US government is working now differently with commercial companies, you're working with Axiom, for example. How do you see the balance in Italy? What we're seeing here is a lot of different countries are looking to Houston because of not just NASA, but now the commercial entities. And we're seeing a lot of countries, even countries like Italy, that have a very, very rich heritage in space, transitioning a little bit more to more commercial operations. How is that balance changing in Italy between the big government projects that companies like yourself and your supply chain contribute to and the truly commercial? We've seen some great companies from Italy during our various space visits that we've had here. I'm just curious as to what the trends are in your mind in Italy as to compare them to how we're seeing in the United States.
Well, now I believe that the transition from government to commercial is now ongoing. So it won't be stopped. It cannot be stopped, and it is. I think it's good. It's right that this is the right way, the way we are going to. Well, it's a change, really a change of how we make business. Because normally, if you have to go to a, if you are working at a government level, normally you say, hey, look, this is what you want to do. This is what the cost is. Pay us and we develop. It's not easy because space is not easy, but that is the model. Now, when we go commercial, we normally have to invest in our technology first. We have to find the money to do that. We have to be clever to select what technology we have to go on, because we cannot cover the complete spectrum of technology. And this is why we partner, by the way, with other SMEs. So it's a completely different way. And by the way, from an engineering mindset, this is we are discussing also a lot that with our engineering universities. We have to change from the question, what have I to do, government, from I will do this because I think that is important. It's it's a completely change in mindset. Speaking of how we have relations with US, I think now any company in Europe and us as well is thinking how to grow commercial in the States as well. So it is not, I mean, I don't think I disclose any secret that we are planning to be much more present in the States, and of course Texas and Florida are the target.
So maybe time for one last question. Yeah. Coming out.
How important do you think SpaceX is in the whole idea of the acceptance of commercial involvement with space? And does the current leader of that make you nervous? SpaceX, right?
Well, SpaceX is the example on how to move commercial. They've been, well, in my opinion, what SpaceX has done up to now and is doing is amazing. I think any of us remembers when Elon Musk said for the first time, we are going to land our rocket, to go back our rocket and land it vertically. I think 99% of the people laughed at that idea. When we all saw on the first time the two boosters coming in parallel and landing, I think that was the explanation of why SpaceX is successful. They dream, they think very, very, very far in the future, and especially they are not afraid of failures. And this is something that we all have to learn on how SpaceX is working. They normally think that any failure is a success because they learn. In Europe, at least, as we are not yet ready. We are not yet there. We are terrified of a failure, especially for a government program.
And I think that's the message for us all this week. So let's thank Dr. Provera again.